Hello everyone, and thanks for joining us today at Exar headquarters in sunny Fremont, California. I'm Eric Pitana, Director of Marketing for the Power Management Group, and during this brief video we will give you an overview of our Exar latest offering in high power, high brightness LED drivers. A little later, Mr. John Cronk himself will make a guest star appearance and demonstrate some of the features of our latest products. Why don't we get inside now? LED-based lighting solutions are becoming more and more popular in numerous and various applications as LED provide a superior performance, reliability, and efficiency. They are lightweight and allow creators and architects to now work with light in ways never done before. Exar provides a wide and complete range of solutions for LED-based general lighting applications, from LCD and keypad backlighting functions, flash drivers, to high-power LED drivers. Exar's portfolio covers a unique set of architectures to choose from. Studies show that the typical LED-based lighting application is a single channel, one LED operating at about 350 milliamps, derived from a 12-volt voltage input, with a step-down or buck architecture. The next current steps being 750 milliamps and 1.3 amps. Exar recently introduced two new products, the XRP7603 and XRP7604, capable of driving LEDs respectively at up to 500 milliamps and 1 amp. These devices complement our existing SP7600 targeted at LED applications ranging from 1 to 2 amps. This family of buck converters operates up to an input voltage of 29 volt, is capable of driving one or more LEDs, and is fully pin-to-pin compatible, providing an easy way of implementing a scalable and evolutive solution capable of migrating as current and brightness requirements increase. Last but not least, Exar's family of LED drivers require less than 10 external components to operate and is offered in a green, halogen-free 8-pin SO package. And now, the one and only, the one that you've been all waiting for, Mr. John Cronk himself, who heads our application department, will demonstrate some features of our products. Let's go meet John.
Hello, my name is John Cronk, and I'll be giving you some details about the XRP7603, 4, and the SP7600. So let's take a look at some of the applications of the XRP7603 and 7604. One of them is the MR16 bulb, very popular application, primarily driven out of Asia. Another are small portable LED projectors used for presentations, and then aftermarket automotive. The XRP7603 and 4 have a maximum input voltage range of 29 volts and make it appropriate for those type of applications. Now, the demo board, if you take a look at this slide, shows a fairly reduced number of components. One is the compensation for the part is internal, so there are no external compensation components, and there's no large output capacitor. There's no capacitor required. So let's take a look at the performance of these parts. So what I'm showing here is a 1 kilohertz dimming, and right now you can see that the on time is very short. I've got it set up for a 20% duty cycle on the input signal, and we're getting a very small output. Now the reason for that is that there's a delay time from the point we turn on the XRP7603 and 4 to the time that the current actually starts to ramp. So because of that delay time, we're still ramping when the signal tells the part to turn off. If we were to increase the duty cycle, now you can see that we're getting a square wave, and this is an artifact of the digital scope. It's not running unstable. And we're getting closer to what the duty cycle is that we're putting in from our signal generator. So one thing to remember is, looking at this foil next, is that the polarity of the PWM signal is reversed from what you're used to. Now, let's go ahead and take a look at some of the details of this board. So I'm going to go ahead and turn off the power. But here you have the entire solution. So here's the SO8, that is the XRP 7603 and 4 demo board. On the left is the entire solution with a very small inductor. The reason the inductor is small is it's a 1.2 megahertz clock frequency and keeps the entire solution size very small. In the middle is a K2 emitter. On the right are 3 slots for Rebel LEDs, and then lastly on the far right is the connector for the Future Lighting Solutions emitter board. Lastly, I want you all to remember to use the LED Lab design tool for selecting LED drivers from Exar.
Hey John, sorry to interrupt, but this is all the time we had for today, and I'd like to remind you all that all this information that has been presented to you, as well as datasheet, application notes, product flyers, is available on our website at www.exar.com. With that, I'd like to thank you all and see you next time.
When did we start allowing marketing into the lab?